So in grade 9, you did things called number systems. You have two different types of numbers, right? It's either a number can be real or non-real, right? So it's either a number can be a real number, which you denote by R, or a non-real number, which will denote by not R, right? So the definition of this one is straightforward. It's any number that falls within a number line, right? So any number on the number line. Then here I'll give you a cheat code to remember. But define a non-real number, you'd say it's a number that involves a square root of a negative number, right? Let's think about it. If you had square root of -1, then you'd get an error in your calculator. If you have a square root of -2, you'd get an error in your calculator, on and on and on. So we are going to define it like this. We are going to say it's a square root of -I, where I is greater than 0. So if you punch any number that's greater than 0 to the square root of -I, you would always get an error in your calculator. Then that's your non-real number. Right? Let's say I is 10, so it's going to be -10. You punch -10 in your calculator, you get an error. So keep in mind, I only said square root, right? Cube roots are different because you can get a cube root of -9. You would get your answer is -3, right? Which is something I'll explain later for you to understand and whatnot. Then let's dive deep into real numbers and see what types of numbers do we have. I'll try and zoom out here. So under real numbers, we have two types again. So we have a rational number and also an irrational number. Irrational number, right? So I know they use Q for this one. So it's Q. Then for this one, you are going to use not Q. So let's get you both definitions and get to understand what are these. Let's start with a rational number. So a rational number, let's define it like this all over. A rational number would be a fraction where the denominator is not 0, right? So we can express it like this. This is the first definition. So it would be A over B, where B is not equals to 0, and also A and B are integers, right? Yeah, if you see a number that you can identify as a fraction and the denominator is not 0, that's a rational number, right? Then other condition would be it has to be an integer, a whole number, a natural number, things like that. Another thing, you can also say a mixed fraction. Mixed fraction. And the last two conditions, it would be it has to be a terminating decimal if it's a decimal. So it has to be a terminating decimal. So a terminating decimal is a number like this one, 0,125. It doesn't proceed and say 1, 2, 5, 9, 10, 11, 12, things like that. And also, it has to be a recurring decimal. Sorry, I'm rushing there. So a recurring decimal, it would be 0,11 or 0,1212. Then they put dots there, then you know like it's repeating. Let me just use 2 because they would have just said 1 and put a dot. So you know it's repeating 1, 2, 1, 2, 1, 2 after the comma. So yeah, that's your definition for a rational number. And let's define what's an irrational number. So If you now know what's a rational number, then the opposite of that would be an irrational number. It would be a non-terminating decimal, a non-recurring decimal, and last 2 points, it would be, let's say, a square root of non-perfect squares, right? So square root of what's a non-perfect square? A number which is not a perfect square. So it would be a square root of 2, square root of 3, square root of 5, square root of 6. And lastly, we have cube root of a non-perfect cube. Don't mind my handwriting is bad, but I'll try to write better this time, because then here it will be cube root of what? Let's think. Cube root of 3, cube root of 5. Numbers like that. You can say cube root of what? Let me think. 2 times 2 times. So you can say cube root of 6, because cube root of 6 is 2. Things like that. Right? So we're done with the definition of an irrational number. Then let's go deeper into rational numbers, because you see there are things like integers, whole numbers, natural numbers, and all that. Let's go deeper and define the rest. So under here, we know we have an integer. Then we need to sort of like understand what's an integer. So an integer is identified by Z. I'm not the best with writing these signs, but yeah. It's numbers from negative infinity to positive infinity. It will be -4, -3, -2, -1, 0, 1, 2, on and on and on, right? Then we have what we call a whole number, which is denoted by n. There is 0 there, which is a number that starts from 0, 1, 2, 3, on and on and on. And lastly, we have what you call a natural number, which is n, which starts from 1 going on. And we're done. Okay, so let's go through the examples that I have here. So they say state whether the following number is a rational, irrational, or neither, right? So if you look at A, you can see it's 0.5, right? 0.25. And under rational numbers, I defined it as non-terminating decimal. So this would fall under rational numbers. I'll just Q there. Then we have -2. So -2 falls under integers, and integers fall under rational numbers, because you can write them as a fraction, as A over B. Then we know this is also a rational number, right? Then pi plus 6 is 3.14 wara plus 6. So this is a non-terminating decimal or a non-recurring decimal. So you identify this as a rational number. Then something interesting here, you'll see that we have -16 inside the square root. And remember, when I defined an unreal number, I said it's -I, where I is greater than 0. Then this is a non-real number. Then lastly, the rest you'll try and do on your own, but lastly, we have square root of 16, which is made up of square root of 4 times 4, which is 4. So this is an integer, and you can write in a form of 4 over 1. So this falls under what you call rational numbers. Do the rest of the examples and see how it goes. Bye.